Hi everyone, this is Sunny Kumar from Mathematics and Computing Part 2 from IIT BHU, and I am back again with daily Leetcode Explore problems, and today the problem name is convert BST to greater tree. So let's jump directly into the problem statement and understand what the problem says. So basically in this problem we have been given the root of a binary search tree, and we have to convert this binary search tree into a greater tree where the greater tree has some meaning that I am going to tell you now. Okay, so let's move on further. So what is greater tree here? Let's understand this first. So greater tree is basically a modification to the original BST where each node's value is going to be replaced. Let me write clearly, is replaced where each node's value is replaced by the sum of all the nodes values. So each node's value is going to be replaced by the sum of all nodes value whose which is actually greater than or equal to current nodes value. So basically our new tree, greater tree, will have each node's value equal to sum of all the nodes values of the original BST whose nodes value is greater than or equal to the current nodes value. So for better visualization, let me move to our visualizer of Leetcode. That is, as you can see here, suppose we are at a node, current node's value of original BST, that is, you can see 6, then our greater tree will contain at this position, at this node, the value equal to 6, as you can see, 6 plus 7 plus 8, because 6 plus 7 plus 8 are all the nodes values whose value is actually the greater than or equal to the current nodes value. As you can see, current nodes value is 6, so all the nodes values whose value is actually greater than or equal to the current nodes value will be summed up and stored in the current nodes values. Okay, so current nodes value is going to be modified. Similarly, suppose here you are at nodes value equal to 1, then this nodes value is going to be modified. So what would be our modified value? So our modified value would be the sum of all the values, all the nodes values whose value is greater than or equal to the current nodes value. So our new value would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So how we are going to do this? What would be our approach to solve this question without using a extra memory? So that is using a constant memory. So how we are going to do this? Let's move further. So our approach would be traverse the given binary search tree in reverse in order fashion. So the one thing that our viewers will think, why we use a reverse in order fashion of traversal of the given binary search tree. I will tell you also. And our next approach would be maintain the prefix sum variable to update every node. So let me write now. Suppose we have been given an array. Let me write given an array, and we have to calculate. We have to, let's say, update each value. Let me write update each value. Update each value with sum of all the values greater than or equal to current value. Okay, then what we are going to do in this case, suppose we have been given an array and we have to update each value with sum of all the values greater than or equal to the current value. So, and what would be our approach in this to solve this question? Just basically what we are going to do is we are going to traverse the array from the biggest element. That is, if we sort the array in ascending order, then we are going to maintain a variable which is going to store the sum starting from the index equal to n minus 1 to the index equal to 0. That is, let me say, suppose we have a sorted array like this: 1 2 3 4, 5 and 6. Suppose we have a sorted array like this, and we have been asked to update each values with sum of all the values that is greater than or equal to current values. Suppose we have encountered 3 and we have to update this, that is we have to modify this value. That is what we are going to do, is we are going to take prefix sum up to this, and we are going to store this into our current nodes value. That is we are going to modify this. Similarly, what we are going to do this in our given question, that is we have to convert this BST into our greater tree. What we are going to do is, suppose as we all know, our in order traversal will gives the nodes value in ascending order, as we all know. So, what in this problem we have to convert into greater tree, that we have to traverse from the biggest element. So, what would be our approach in this problem would be, approach will be traverse in reverse in order fashion. Why we are going to traverse in the reverse in order fashion? Because we are going to take the max biggest element first, then the smallest, and each time when we encounter the current node, we are going to update the current node's value with the sum up to that node. That is prefix sum, or you can say suffix sum, starting from the last node, that is from the biggest element up to the current node. So we are going to traverse in the reverse in order fashion, and maintain a global variable for suffix sum. So similar to the case in the array, that what we are going to do is we are going to take the suffix sum variable, and we are going to iterate from the last array value, that is from the biggest element. If the array is sorted in ascending order, then we are going to traverse from the back side of the array, and each time when we encounter a certain index, we are going to update that index value with our global suffix sum variable. That's what we are going to do in this binary search tree. We are going to traverse this tree from the biggest element, that we are going to traverse the way in the reverse in order fashion. That is, this will give the first as the biggest element, then the next biggest element, sorry, the next element which is just smaller than the biggest element. And similarly we can update each nodes with global sum variable. Note that we have to also update the global sum variable accordingly. Okay, we have to update the global sum variable accordingly. So what we are going to do is we are going to traverse the in reverse in order fashion. Let's move on to the code to understand much better. So note that here I have taken pref sum, or you can say, you can write suff sum, because we are going to traverse from the backside, that is from the biggest element. So we are going to write a suffix sum here, and what I am going to do is I am going to traverse in a reverse in order p. So each time if root is null, I am going to return as it is. Note that in order traversal, first we are going to move to the roots left. Note that here I am using a reverse in order traversal, so first we are going to move to the roots right. Then now whenever after moving to the roots right, then we are going to come to the root. Then when we come to the current node, what I am going to do is I am going to update the current node's value with the global sum variable, that is suff sum. As you can see, I am going to write suff sum because I have modified the above variable names. So I am going to write root val is equal to root val plus suff sum, that is suffix sum. And each time also I am going to modify our suffix sum variable, as you can see. Okay, now also our suffix sum variable up to the current node would be what would be assigned with the value equal to the current root val, because I have already updated the root val here, as you can see. Okay, now here as you can see, I have updated the root val with the current value plus suffix sum. So our new suffix sum up to this node would be assigned as root val. Also note that this traversal is actually from the biggest element, then next element which is just smaller than the biggest element. I am going to do this just similar like the sum, just similar to the traversal in the array from the back side, in if the array is sorted in ascending order. Then I'm going to traverse to the roots left, and note that in the our given function, what I've do the first I have called the reverse in order to modify every roots no that is every node's value. Then finally I'm going to return the root. So this would be our modified BST. What this is not, let's say, modified greater tree for better understanding. Okay. So if you have any doubts, please do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, do subscribe to my YouTube channel for latest updates. Thank you for watching this video.